All right, let's get started. Kia ora koutou katoa, and welcome to event number 2 of ArtGenZ. Thanks so much for joining. Really privileged to have your company, especially in the mad rush in the lead up to Christmas. We've had a really good number of people sign up. I see we've got about 40 online, and I'm sure many will be watching the recording later on. So let's get started. So today's session, a little bit different to the first. Today we're going to do a group training session and take a deep dive into the Leica Cyclone 3DR software. So the session is really designed for advanced users, and we're going to take a look at some of the advanced functionality. But for those of you who have joined with no previous experience with the software, it'll also be a really good overview of the power of the software. So I'm going to start with a short introduction for those new users, and then I'm going to hand over to Jennifer Clare, who we're really privileged to have on the line all the way from Brisbane across the ditch. So Jennifer works for C.R.Kennedy, the Leica agent in Australia, and she has a really long history with Cyclone 3DR and 3D Reshaper, as it was previously known, having worked for many years in the development team in France. So she's a real expert, and you're in for a treat. And then we're going to have short breaks for questions after each of the exercises, but we'll also allow some time at the end for any further questions. So please make use of the chat and question panel on the right, in the panel that you can see in your webinar, and we'll address those questions when we have time. So a short overview of Cyclone 3DR. So as you can see in this illustration, it really fits into the final stage of the reality capture software workflow. So after you've captured your data with whichever reality capture sensor is appropriate, so it could be a laser scanner, could be a mobile mapper, could be a drone with imagery, and you've prepared your data in your registration software, your photogrammetry software, and published to an open format or to a vault such as Cyclone Enterprise. You then consume, analyze, and deliver digital data through Cyclone 3DR. So it's a seamless extension of the Cyclone product family. So you can take in obviously the proprietary Leica formats such as the LGS file, or connect into a Leica Cyclone Enterprise server. But more than that, you can, as it's an agnostic software, it's open to a really long list of industry standard formats, in point clouds in particular. So all of your E57s and your LAS files and so on will come into Cyclone 3DR. It doesn't discriminate on sensor type, so it could be UAV data, laser scanner data, whatever, it doesn't matter. Then the software has some workflows for particular industries. So there's a standard module of the software, and then additions for AEC, or the building space, survey workflows, and then there's a specific module for tank inspection. And then should there be a function which is not available in the standard user interface, there's a really rich scripting engine available for you to customize your own workflows. So it's powerful in a wide range of applications. The key features of the software begin with point cloud management. So it's really powerful in terms of clipping, slicing and dicing your data, cleaning your point clouds with autonomous routines or manual modules. It then has, and this is where the real power in the software is in the meshing algorithms. So it has fantastic methods of creating complex meshes or meshes of surfaces. You can then extract features from those meshes or from the point cloud directly. And then there's powerful inspection and comparison tools which output reports that you can deliver to your customers. And then there's a scripting engine as well, as I mentioned earlier. So there's a surveying module which is focused in on typical survey type workflows, such as creating terrain models, tunnels, stockpiles, volumes, alignments, all that stuff. An AEC module, which focuses on BIM type data formats such as Revit files or IFC files, and allows you to compare those files with point clouds or extract things such as floor plans or basic building models. And then there's a tank specific module, which is all around the API standard, which is widely adopted in New Zealand for tank inspections. And all this functionality addresses a really wide range of sectors, right through from the traditional land surveying through to architecture, construction, civil engineering, the works. So that's a very brief overview of the software, and you'll see the power of it over the next hour or so. So now I'm going to hand over to Jennifer, and we've got 3 data sets to demonstrate 3 applications or workflows. So to begin with, we're going to look at the complex meshing on the Knox Church, which is in North Canterbury in Cheviot. So I captured this with the RTC 360, and due to its kind of interesting construction, which it's a church built of river stone, it has some really interesting geometry, and it shows the power of the meshing functionality within 3DR really, really well. So we're going to work through to a textured mesh. And then in application number 2, this is a UAV data set captured up in Marlborough with an EBX, a fixed wing drone. The data was processed in Bentley's context capture software and a point cloud exported for use in 3DR. And then finally, we have a road scene captured again with an RTC 360 to show the power of feature extraction within Cyclone 3DR. So, without further ado, I'll hand over to Jennifer, who's going to show you through the software live from Brisbane.
Good morning, everyone. Thank you, Lennon. Can you just confirm you're seeing the right screen from me? I've got the PowerPoint on it.
Yes, I can hear you. I can see Arch NZ.
Okay, awesome. Morning, everyone. It's great to see a lot of attendees this morning. Thanks for joining the session. So we'll dive straight into it. And as Lennon was saying, we're going to see 3 exercises, and we'll start with the meshing, because that is definitely still the heart of 3D Reshaper, even though there's more and more functionalities added to it all the time. This is still very much the starting point of a lot of exercises. So that's what we're going to look at, and I'm just going to start my little timer so we make sure we are sticking to the time we've got. So this exercise is going to be a little bit longer than the next 2, because we'll try to go a bit into details about the meshing, because most of you who have already used the software, you would have questions about it, and those of you who haven't seen it yet, you'll see the powerful tools we've got in there. So meshing, but we'll see also all sorts of little tools afterwards to improve that mesh and clean it, etc. So we'll start straight into it. I'll open Cyclone 3DR. So I've got a few slides that explain a bit the workflow we're going to go through, but I'm going to mainly be showing my screen and doing nearly everything live. So hopefully everything goes well and as expected. So here we go. So I've got 3DR open, and I'm a big fan of the drag and drop to open some data. So I'm just going to open that here. I've got an LGS file here that Lennon sent me from this church. Just drag and dropped it into the scene, and I see it wants to import that file, and we're importing an LGS, and I can say import straight away. What's nice with looking at LGSs is that you see the point cloud instantly. There's no time for it to be loaded into the RAM because LGS has that technology in the background that simply streams to the point cloud. We can see that this is read only through the CloudWorks menu. So the CloudWorks menu in 3DR is included in the base license, so every one of you will have it. And some of you might know CloudWorks from other packages like AutoCAD, BricsCAD, etc. So it's very much the same menu in there. Just give it a second. When you're sharing your screen, sometimes it jumps. Here we go. So what's happening though is that you can do a certain number of things straight away on that LGS file. However, there's a few algorithms that you cannot play straight on it necessarily. So if you're after doing a few measurements and so on, you could do it straight away. Otherwise, if you're after meshing, texturing, etc., you do need to convert the cloud into a 3DR cloud. So that's the first step we're going to do. And so the idea of this webinar is really to show you all the steps that we would do in a real workflow. So in the CloudWorks menu, at the very end, you have a tool that's only specific to 3DR, which means convert the project. So whatever is visible at the moment, those points will be kind of translated from a 3DR, from a LGS streaming cloud to a 3DR point cloud. So when you convert the project, you have the choice to choose how many points you want to convert to a 3DR point cloud. And what's nice is that no matter how big the LGS is, you can enter a value that makes sense for your computer, which means that you'll be able to work on the data, even if it's a really huge point cloud. We'll see in the last exercise we do today how you can do it to only convert a part of the cloud and not the entire point cloud. What's interesting as well is that this LGS contains images because those images come from the RTC data. And it would be a shame to not get them through because they look pretty good usually. And so here I also have the choice to convert the images through as well. And so that's how at the end I'll be able to texture my mesh thanks to the images from the scanner. And the great thing about that is that you'll see straight away once the conversion is done, you'll see that those images are already placed in 3D. And so there's literally nothing to do. You just have to select them, select the mesh, and there will the texture will be applied on the mesh automatically because all the information about the position of the imagery and the orientation of the imagery is already known within the LGS file. So this conversion always takes a few minutes. In this case, it's about 4 minutes, so it's not too long. From the testing that the team in France had done, it's always still quicker to actually open the LGS and then convert than to actually spend the time exporting potentially an E57, then importing the E57 in the RAM. I don't have like a percentage for you, but it's usually quicker. So for those of you who are using Leica solutions, you can always remember that you don't have to export anything specific for 3DR. You can just get away with the LGS itself, which is really what Leica wants to do here, and having a seamless workflow between one package and the next one. So 3DR is still very much its own platform, but we'll see how you can read all the Leica data very much directly. And LGS is one example of it. Here we go, we're done. So now we can see the real cloud and we see where the scan was positioned. with the spherical images. So my CloudWorks group is now hidden, and I've got my real cloud in here. And if you just leave your cursor on it, you can always see how many points we've got in the cloud. And I've got here 31 million. And I said 50 million from the conversion. What's happening is that it had less than 50 million points. So it just converted all the points for me, which is great because that's probably what I wanted, to have as much detail as I want in it. So I'm going to hide the images just to start with, and we're going to go straight into it. So just a little thing before I start really with the exercise, it's just something for maybe the advanced users, is that in the settings, since 3D Reshaper became Cyclone 3DR, you have another way to move inside the 3D scene in there, which is very much more the same way as in Register 360. So by default, when you first install the software, it's this mode that would be active. And it's great for all the new users because you don't have to get used to different ways of moving inside the software. For users who've been very used to 3D Reshaper, there is still the possibility to change to that. And I have to admit that I'm not very good at it, so I need to use it in the 3D Reshaper way because I'm way too used to using 3D Reshaper. So don't get confused if you see me turning in a different way. It's just because I've got that on. Little tip there. So there's one option that's extra when you use the 3DR, is that you have that little tool there to keep your data vertical. When you're using the other way, the Cyclone 3DR way, you don't need that because it's done automatically for you. So potentially it should be easier actually. Here we go. So now that we're in here, we have to, the main thing before starting to mesh something is to understand what we would like to mesh and what we would like to get out of the mesh data really. So in this case, we chose to work on a beautiful example and show how fine the mesh can become so that we can really show detailed meshing on something like this. So we really want to have as much detail as we want here, and so on. There's one thing that 3DR is not that good at. It's meshing like vegetation and bushes. If it's very dense, it could potentially create a bit of a shape there, but if you've got a tree or something like that, it usually looks a little bit messy. So it's usually better to just get rid of it. And so most of the time before you start meshing a cloud is that you need to clean it to get rid of things that you do not want to see in the mesh. In this case, that does look very clean already. Lennon's done a nice job at trimming it, etc. But I would like to show you, and we'll see this tool a few times, in the clean menu, we've got a brand new tool called the auto classification. So that's a new tool that came into the version that just came out maybe a month ago now. So it's 2021.2. And so the idea being that you can just play that tool and it will classify your point cloud in pre-created classes or classes that you could potentially edit. So by default, you've got ground, vegetation, building, hardscape, etc. And you'll see that it does quite a good job here. I'm going to click on preview. It does quite a good job here at removing the vegetation. So here, this data is not too complex, so removing it manually would be fine with the classic clean and separate. But I thought I'll show you that filter as it's a brand new tool, and you'll see through the exercises today that it works on all type of data set really. So that's going to take a couple minutes here. What's nice is you can always move the scene while it's computing. So if you want to keep inspecting the data, you can always do that. Here we go. So what we'll see now is that in the point cloud, each part of the cloud will have a different color that's based on the class. So you can see that the ground is in brown, just like here. The high vegetation is in dark green, like here. Then the building is in gray. And you can see that it's done a pretty good job at detecting those little plants at the front like that. So I'm not going to go too much into detail here to improve that. You can actually improve the result manually. For the sake of this exercise, that's going to be enough. Here we go. So it's still one main cloud, and as you can see here, when you click on that, you'll see that it is a new type of representation. It's called classification now, so I can still change it, but it's one cloud. So if I want to get rid of the vegetation, or at least hide it and not mesh it, I do need to come here, explode by class. So I'll do that, and that's very instant, really. And so now I'm going to have as many clouds as I have classes in there. And I can easily then even modify, like trim the cloud myself if I want to. So what I'm going to do is that I'm going to hide just the vegetation, and I think hardscape is mainly noise in this case. And what we'll do is that we'll actually mesh the ground with the church, so that I can show you a little bit some extra tools afterwards. So you can actually mesh two clouds that are not grouped in one. You just need to select them both, and the 3D meshing will always create one mesh out of the whole selection. So I'm not doing any more cleaning, so that you'll see a little bit. I've got a few noisy points here and there. You'll see what they look like in the mesh, and you'll see how we can potentially clean that a little bit in the mesh afterwards. So the 3D meshing is always this function when you've got a 3D mesh to do. So in the surface modeling menu, and here we start. So in the meshing, it can be a bit scary at the start because you've got quite a few settings, but I'm going to try to give you tips on what to choose really. And what you should always choose is meshing in 2 steps. So the others can be useful for some very specific sort of point cloud, but what applies to most of the time is the meshing in 2 steps. And I'm going to be explaining what that does. Underneath here, you've got a value saying average distance between points, and it's got a default value for you in here, so that if you've got no idea whatsoever what to do, you can actually just click on preview and see what that does, and then you can modify that. So that's what I'm going to do right now. Very often that value will give you a result extremely quickly. And here we go, that's what we have. So looking at that, okay, we've got the shape, but I don't think anyone would be happy with that. If you were after a simple modeling of that church, you could start working with that. That would be perfectly fine. So that's something you do need to keep into your mind, is what's your goal when you're meshing? And I'm probably going to be repeating that a few times. A little tip is that whenever you are in a function like that, you can click right in the 3D scene and change the representation. I'm going to just change to flatten wire to show you the point clouds in there. So that value here, average distance between points, is not the distance between points in the point cloud, but between points in the final mesh we're having here. So this is what is happening here. What you can see, hopefully, and if I align on X and Y, you can see that our mesh is extremely regular. So it's regular in X, Y, and Z. And so the size of the triangles is approximately 200 millimeters, which is the value we've got here. And you can see that thanks to the little scale like that at the bottom. If you put it on top like that, that's what you see. So what's happening here is that we just have a regular mesh all over the area. Now we have to see what we would like to do. We probably want to have more detail in that mesh for our exercise. So what I can do is reduce that value. So the whole thing now is, this value is actually probably the most important one you need to work on when you're meshing. And the whole idea is to try to get a mesh that has as much detail as possible, but keeping as small as possible the number of holes. So I'm going to go straight to the value that we're going to use today, which is 60 mil, which is what I found was the best value for that. So sometimes it's worth testing, like if you're at 60 but you're not sure, you can test 65 mil and 70 mil, like even just a few millimeters difference can make a difference in one or the other area that will make it easier for you to work on the mesh afterwards. So what we'll be looking for is areas where we might have holes that look a bit like crossing each other, or triangles that look inverted, for example. In this first step of the mesh, we really want to try to avoid problem areas as much as we can. So here we go, very quickly actually still, we straight away have way more detail. We can start to see a little bit the stone. So obviously it's still not a beautiful mesh, but we have way more points to work on. And so if I just change to flatten wire, you'll see that our triangles are much smaller. They're about 60 mil big. And so what I'm looking at now is looking whether those holes are okay to work with. And obviously, like what I would expect is to have holes wherever there's a lack of data. So very naturally up here I've got holes, and obviously here I've got a bigger hole. I've got something a little bit floating here. That's something I didn't clean in the cloud, but I'll probably be able to get rid of it. Here we go. So another thing is the hole detection down there. I tend to never use the two bottom options. I always just use the default one at the top. What I found was actually a little bit better was to increase that value just a little bit. So I'll just click on preview and I'll explain a little bit more. So what this means is that wherever there's a hole, this value is by default 3 times bigger than the value you entered up here. Whenever there's a hole, if the size of that hole is smaller than this value, then it's 3DR is going to fill it up automatically. If you choose the next option, try to keep only the external border, it's going to try to fill every hole, but just keep the external border, which is one big hole topologically. And if you choose the other one, a watertight mesh, it will try to actually close the mesh. So you can never do that when you've got a terrain. You can do it when you've got maybe a statue or something like that. Or if you had just the church without the terrain, that would work. Most of the time, just do that, because we'll be filling some of the holes afterwards where we have more control to fill them. So now, because we chose meshing in 2 steps, we have to remember, excuse me, remember that value. And when you say OK, the second step opens for you automatically. And I'll be explaining a few things here. Very often, the best way to go is to choose the first method. So this is where this function has definitely a lot of settings, and it can be a little bit scary. What I'm going to do is that I'm going to set up the right values here, and that I'm going to click on preview, because it's going to take about 10 minutes to compute that. So I just want to start it, and I'm all good, and then I'll explain what this is doing. So why are we having 2 steps? Basically, in the first step, what we see is that the triangles are regular all over. So if I do want to have nice details on the stones in the facade, or the windows and all of that, I would need to mesh with much smaller triangles. If I mesh with much smaller triangles, wherever the cloud is less dense, like at the top of the roof, for example, we don't have the same density as here, so we will start to have a lot of holes appearing. So I just cannot mesh straight away with triangles that are 5 millimeters big, because I just don't have the density for that at the top. So that's why we're doing it in 2 steps. And the whole philosophy is to try to have, in the first step, you try to achieve a mesh that has as little holes as possible, so that you've got a lot of surface to actually work on in that second step. So the whole idea of the second step, refine the mesh, is to improve that mesh thanks to the point cloud. The point cloud is still in the background here. And what I'm saying is improve the mesh to stick to the point cloud up to that deviation error that I'm stating there. We've got several methods that we can use. One is cloud interpolation, one is straight from the cloud, and one is without cloud. So the without cloud is mostly if ever you were given a mesh from someone and you didn't have the scanned data, you could actually run this to still improve the mesh, and it's quite smart in the background. It will try to reorganize the triangles, etc. So you could have a better mesh just by playing that, even without a cloud. Then when you have a cloud, most of the time, what we're doing here is the best way to go, just 2 steps in cloud interpolation. What the interpolation means is that instead of simply adding the real points of the cloud into the mesh at this stage to add the details, it's actually going to look in a smarter way at the cloud. And within the cloud thickness, it will compute which point is actually the best to use, looking at the local noise. So the idea is that you will bring in points that make sense compared to the mesh we already have. And that's where every now and then you might need to actually do a mesh in 3 steps instead of the 2 we're doing now, because every now and then with the first step, you might actually not be able to have enough detail and find that good compromise. And so if you just go straight to cloud interpolation, you might not have enough triangles to really just catch back all that detail. So using the second option here, refine mesh from cloud, will actually insert inside the mesh the real points from the cloud. So you'll have settings that are very similar with a deviation error. And so if you use mesh from cloud with a deviation error of 1 mil, that means the current mesh has to stick to the full point cloud at max 1 millimeter. So you'd be adding nearly all of the points back into the mesh. So that's something that you can do. And I'm actually going to show you how that works. Because you'll see that doing what we're doing now, we're probably not going to get all the details on the door, for example, because the door at the moment looks pretty flat. So we don't have enough points yet to really get all the details. But you'll see that doing what we're doing now, we'll have the stones very beautifully and all the details around the windows and all. So hopefully that was clear for everyone, but I'll be taking a couple questions if we have time at the end of that first exercise. So now looking at those options here. When you're meshing from cloud interpolation, you always refine with a deviation error. That's what it is. And here I've got a deviation error and I've put 1 mil in there. Very often, a good value to use is a value that depends on what you used, like what the size of your triangle is. So our triangles here are 60 mil, that's the size. So very often what I would put here by default, but before having any ID, is a value that's 100 times smaller, so 0.6 mil. And that's the tip you can try to remember when you don't really know what to do. Here, 3DR actually enters default values for you that should make sense. I see that the value at the top is quite often a little bit small. So what happens is that if you compute with a too small value straight away, it might take a little while to compute. And then at the end, you're looking at something that might just not be good enough, but you spend a lot of time. So I would recommend to use a deviation error that's maybe a little bit bigger, just to have a first preview that doesn't take too long. And then if you see that it's actually very quick and you see that you can go for more detail, then you decrease that value. And so that's how you do it. If you want more detail in here, you decrease the value here and you'll get smaller and smaller. So there will be a limit, obviously, because it will depend on how many points you've got in the point cloud and the quality of the point cloud anyway. But here you could enter values at like 0.1 mil or things like that. You will see that it will make thinner triangles and more details in there. Next value is the maximum number of triangles. This one I usually just leave it as default. I don't touch it. It's usually big enough, what the value that you've got here. It's just a way to control a bit that the mesh doesn't get out of hand in its size really, and that you'll still be able to work on it. So 4 million triangles is probably a big mesh already, but that will be good because that's what we want to see. Then minimum triangle size. Usually here, the value by default, I find it a little bit big. I always enter 1 millimeter. That's just what I do. Because I always think, I mean, in all of our applications, whether it's drone, RTC, static scanning like that, I don't think we can pretend to go under the mill with what we're scanning, but basically that tells you the size of the detail we can be looking at. So if you're really after very sharp things, you could enter a smaller value here, but I usually think that's good. Increasing that value will just limit a little bit the quality of the detail that you can actually bring back into the mesh. So whatever I'm meshing, I always enter 1 mil in there. Then you see you've got an option saying refine with point evenly spaced. We just never use that. It's very specific, so always use the deviation error one. The distance one is always ticked by default, so I would say never touch it, then you know it's always there. And it's showing you here the size of the triangle that we use, so 60 mil. And this is what you should always do by default. So what does that mean? That actually is very interesting because we've got a mesh right now, and in the background you have the point cloud still. You can't see it at the moment, but it's still there. This means that if a point in my cloud is actually further than 60 mil from the mesh at the moment, we actually don't want to use it in refining the mesh and finding which point to use to refine the mesh. Because if it's at more than 60 mil right now from the mesh, it means it's probably some noisy point around. And that might be the case with a little bit of vegetation that was remaining, for example. So you can see here that thanks to that, you don't need to go into necessarily too much detail in cleaning the cloud, because this is going to remove some of the points that could be still problematic. So obviously it's always better to clean the cloud as much as you can, because you will get better results if you have a perfectly clean cloud, but you're always going to miss some points that are a little bit floating and so on, because no one wants to spend hours just cleaning little dots here and there. So thanks to that, that will improve it. And then the next one is local reorganization. This is always ticked. I don't even think about a type where you wouldn't want to use it, I have to say. Should probably even be hidden, but it's nice to have it because we can explain. So what we're seeing here is that you can see on the edge, those triangles being just regular, they don't really have any knowledge of the real shape there. So what you can see, these triangles, for example, with these 4 points, you'd actually want them to be triangulated, or maybe here, triangulated in this orientation instead of triangulated over the edge. So at the moment it's like that because it's a regular mesh. So the triangles are as equilateral as possible. But with the reorganization, that's actually going to change around the way the triangles are organized so that it will position them nicely along the curves and edges. And the last option here is what to do with the holes. So holes or free borders, and I would always take the refined free borders, which means that the triangles along the borders like that. So holes or free borders means that some triangles don't have neighbors on everywhere around them. So those triangles are also allowed to be modified. And that's nice because that means this border will be refined as well. And potentially that will improve the border for us to go fill the hole afterwards as well, which is nice. And like the outside border is pretty clean here because we have a nice dense cloud, but potentially here it might look a little bit better as well. So we should be nearly finished now with the computation. I might just switch to the slide slowly while it does that. So that's what we've seen, cleaning the point cloud, then compute a mesh in 2 steps, and remember always average distance between points. Then refine the mesh, and I talk through the different solutions available here. And so usually you use cloud interpolation, but every now and then it could make sense to do mesh from cloud then interpolation. And once this is done, then here is a little bit of a recap of what I've tried to explain about those settings here. So always remember the average distance between points, this value, and then if you're refining in 3 steps, when you're refining from the cloud as this middle step, you just divide this value by 10, and then when you do the cloud interpolation, you divide by 10 again. If you're not doing the middle step, you're just going straight to the cloud interpolation, which is most of the time, you can just divide this value by 100, and that's probably the smallest you can go. So you can see that for our example now, I didn't go to 0.6 mil, I just rounded up to 1 mil because we're still a little bit conscious of time, even though we are taking the time to do it. I didn't want to go too far. So you could go potentially a little bit further. Let me go back to it. Here we go. So it's nearly done. And at the very end, sometimes it does think a little bit more because it needs to show this, this mesh. So it's the graphics card that's going to think a little bit. So I'm just going to move forward to explain you what we're going to do next. What we'll do next is that I'll show you a couple things on how to improve some of the areas. So there's really a lot of tools inside 3DR to improve a mesh, and that's the great thing, is that it's not just a meshing software, it's also a software that has all these features to actually work on the mesh and improve it. It's not a black box that just gives you a result. You do have all of those tools. So I'm going to show you how to fill some of the holes. I'll try to show you one that could be a little bit tricky, but those can be okay. And then I'll show you how to improve just a specific part as well. So let's go back to that. Here we go. So now it's computed. So it took about 10 minutes. And I'm going to say okay to validate that. And you can see how we can now see those stones very well in there. So I know that the mesh has been well computed when in the smooth representation like that, you cannot detect that the shape of the triangles. And that's exactly what we're having here. That's why it's called smooth as well. So if ever you wanted to see the stones much more, then you could go further in those details. And if we have time, I'll show you we've computed another mesh, but I think I might have to pass on that just to go further. So this is what this mesh looks like at the moment. And what we can see is that here we don't have as much detail. So I'm just going to show you the triangle so that you can see that. What's very interesting in 3DR is that whatever surface is flat and was already very close to the point cloud didn't need to be refined. We'll keep our bigger triangles, but every area where we have details has those smaller triangles now. And here you can see that the triangles are really organized along the edges, and that's that local reorganization. So what I'm going to do now is that I'm going to explain you how we could just improve a little bit of the point cloud if we wanted to have the details on the mesh as well. because that's a nice workflow if you don't want the full detail on the entire mesh, but just on the little bit. I'm showing the point cloud now at the same time so that you can see that I'm not seeing the iron work here on the door. But if I want to retrieve that, there is a way to do that. And one way to do it is actually to cut that part from the cloud. So I'm going back into the clean menu and do a clean and separate. And what I'll do is that I'll just take a little piece of it. So I'm going to go from here to there and here to there so that we have a little bit of an area like that. So cleaning manual is easy. You just select points like that, click on enter. One thing that could be useful is that when you're in an area like that, you're selecting, that's actually selecting through the full point cloud. So if you want to make sure to select just the front facade, you can grab the edge there and just create a box around that area that you want to select. So that's what we're doing here, just grabbing that and creating a box. And then I'm going to split this and say okay. Then hide the main mesh, which is this one. And here, so this one is called building one, and I'm going to hide it so that I can see what will happen on the mesh. And now I select the mesh, and with control, I also select the cloud. And in a surface modeling, I can go straight to that second step, the refine mesh. And what I have to do here is first do the mesh from the cloud. And here we'll go and do 2 mil, and I'll preview that. So that's going to take a bit less than a minute. So this is the other way. So now you can see that by meshing with the real points of the cloud, it looks messy because we have basically all the noise from the cloud back into the mesh. But now I can kind of start to see the elements that I'm after. So I'm going to say okay. And now to finalize the mesh, you should always, so I'm going to do the same, select the mesh, select the cloud, always finish your mesh by doing the refine with the cloud interpolation, because this will really create that nice and smooth looking point cloud. And here I'm going to do what I said, which is divide by 10. So instead of 2 mil, I'm going to do 0.2. And that's what we need. So preview. So this step here always takes a little bit more time, the interpolation. So it should be about 2 minutes probably. But you do need to always finish your mesh with that if you do the middle part.
Would you like to take a question while you're waiting, Jennifer?
Yeah, I was going to say that if you've got some available. Yep.
Sure. So I've got a question from Rodney. Thanks for the question, Rodney. You explained how you could bring in imagery from an LGS file. Is it also possible to bring in a georeferenced image, say from a drone, into 3DR?
Yes, definitely. So that's a good question. You can also bring pictures, like E57 files can have pictures in, but when you're talking about drones, you can bring in either an ortho image or an image that is georeferenced, like a GeoTIFF image, for example, and it will read the information as well.
Yeah, and if there wasn't any georeferencing information, you could also estimate those parameters, couldn't you, by picking some
so
points
if you
in the
just
cloud?
took a picture with like your camera, or if you had a picture that didn't have any of those information, what you could do is have that dual screen in 3DR where you have the picture on the left and your mesh on the right, and you can pick common points between the picture and the mesh, and that way 3DR will compute how is the picture oriented and positioned.
Excellent.
You can probably have another question if you'd like.
No other questions at present, so feel free to fire them in.
Yeah, if anyone sends question and writes them in, and if we cannot answer to them live, we'll try to answer everyone afterwards anyway. So we'll have hopefully we'll have Q&A at the end, but yes, send your question through so we can answer a few questions while it's computing as well.
Got another one that's come in. The minimum triangle size, which I think you set to 1 millimeter by default. Which
Yeah.
part of the triangle does that refer to?
It's the longest edge of it. So
Okay.
obviously they're not all equilateral, but it's the oh no, for the minimum triangle size, that's going to be the minimum edge of it, sorry.
Okay.
It's the average distance between point is the longest edge, but the minimum triangle size is the smaller edge.
Cool. And one more for now. Question from Caleb. Further to Rodney's question about the the import of images. If you have a calibrated raw image, so it has the position and orientation of the photo, will 3DR read that information?
Yes, you
I
can
seem to remember.
import. You can
Yep.
import your calibration file in 3DR. I haven't done that in a while, but definitely you can also calibrate it yourself in 3DR. Like if you do take all the pictures in the right workflow, you could do that. But yes, if you do have calibration, you can import it. There's in the help file, it's described, I think, how the file should look like to import it straight in and what type of data it's looking for. So you can make sure that you're having a file that makes sense for 3DI.
Perfect. And that minimum triangle size of 1 millimeter, would you still use that for data like UAV data on a larger scale?
I would really use it all the time. So even on a larger scale, because I know it gives me more detail, but if you're looking at something that's square kilometers, then maybe you could increase that value, yes. I don't think it would make a huge difference in the computation time, I have to say.
Yeah.
But it's something you could increase if you're really looking at very big data set, obviously.
Yeah, I think if you had your value for the refinement was larger, then it probably is not going to get down to 1 millimeter anyway.
Yes. Yeah, if the spacing between the points is bigger anyway, is a few meters away, then you'll probably still have some triangles that are small to get those fine details when you're refining, but yeah, not down to the millimeter then. So that looks like it's taking a bit longer than I expected. Hopefully it will be done soon. It's still computing, but it's at the very end.
Squeeze in another couple of questions from Phil. In the first stage of the mesh, what's the main thing you're looking for to make sure you have the right triangle size?
So I would always play and try different values for that average distance between points, so that I can have a feel and look at the mesh and see what I'm getting out of it. What I'm trying to have is a surface that covers the point cloud as much as possible. So minimizing the number of holes as much as possible. That's really my number one thing I'm looking at achieving. And then I would always usually also zoom a bit in some intricate space, just see whether I'm having any area that's a bit troubled, for example, and potentially change the value and see if that area becomes a bit smooth. So if I use a slightly bigger value, for example, so you could potentially improve all that. So
Yeah.
I don't know how long it's been. I don't know if I'm stuck on. Oh, here we go. Thank you. So here we go. So that's the joy of doing it all live, but hopefully you get a good feel out of that. So now we're finally having all those tiny detail back in. So you can see that it is possible to go that low. And here you can really see the transition from one to the other, how much more defined are those stones here, right there.
Yeah,
So I'm
I
going
think
to
that's
say
perfect.
okay.
In response to Phil's question, you can really focus on getting a complete mesh in that first step. And if you've had to sacrifice some detail to do that, then you can use this third step to bring it back
Yes.
from the cloud.
Yes, exactly. Always better to mesh bigger at the start and then go get those details with these functions, the refine mesh. So you can see how beautiful those stairs look right now. They're very sharp and tidy.
Cool.
I'm going to keep going
Yep.
because we need to move on. So I'm going to quickly show you a little bit how to fill one of the holes there. Here we go. So I'm just going to do one because I don't want to go, I'd still want to do the other exercises. So that's one that could be a problematic typically because we've got a bit of noise still here, like still remaining vegetation. So before filling a hole like this one, it's better to actually clean out a bit the border and then fill it. Because if I try to fill a hole straight away, you see all those shapes here are very coming in and so on, and some triangles might be inverted and all of that. So the best thing to do this one in the surface modeling, you can find here the clean and separate tool. So this one works very much like in the point cloud, and I'll show you that you can just delete some points. And what I would typically do is at the top I'm probably okay, but it's mostly at the bottom. So I'm going to start clicking points to go around this area. And it's better to clean a bit wide. Usually that's the best way to go. Click on enter and then just delete those points. Here we go. Okay. I think it's my computer getting a bit slow. It's a bit annoying. I might just save. So that's one thing that you do need to remember with 3DR is that you do need to save your file regularly. Otherwise, you're going to lose everything you've done. So we definitely do not want that. Here we go. I'm just going to save it there because I think that should help with the process. Here we go. So now that border, it's a little bit, it's not very smooth, but at least we don't have any triangle that are creating issues. So then if I go into fill holes, then I can just click whichever hole I would like to fill. So I'm just going to click on this one. And you can do it with curvature filling or without. So if you do with curvature filling, it's going to try to interpolate the shape that are supposed to go in there. I just turned off my camera, hoping that might make it a bit quicker. Here we go. So what we're seeing here is that you see a little bit of a shape coming in because of those steps on the side. So in this very case, I would probably not do it with the curvature. I would probably just do it flat. And I'm going to move forward. Like we could see how to do the steps better, but I think that is going to be too many details. It's better if we move to the next exercise afterwards. So if you just want to fill it flat, you uncheck the curvature filling, but it's always good to say add points inside the hole, because that way you're not just getting big triangles from one side to the other. You're actually having points in there and triangles in there that are roughly the same size as the triangles around it. Here we go. So it's called flat, but because you have the little triangles, it will still follow a little bit the shape. And if I just show the triangles, you're going to see here that those triangles are roughly the same size as the ones around. So it's great because when you close that, you'll see that it's hard to know that there was a hole in there at all. Someone who didn't know the data wouldn't necessarily understand that there was one. So you have to choose whether you do want to fill those holes or not. Sometimes you have to, like if you want to compute a volume or something like that, you have to have a closed mesh. Otherwise, you could choose just not to fill it because you do not want to interpolate anything. So now that we've got that, I'm going to switch to the texturing to finish that exercise so that we've got the whole workflow. And so what we've got now, I'm going to show all of those images. And very easily, I can just select them all and select the mesh at the same time, and then go into the texture menu. And here you can say texture from images. And I'll click on the preview. So you see here that there's a few options to import all sorts of images or do your calibration or estimate the position of the images. So there's quite a lot of tools in there. We're just going to look at one, but there's quite a lot of tools in there. So here the texture, the way it's done is that the triangles are going to understand which image position has the best orientation to it, and then it will take its texture from that position. So typically the door will have its texture taken from either this or that image, but not the side ones. So it's trying to look at the picture that has the most perpendicular orientation to it. And so it does it in quite a smart way. At the top here, you do have, so that's what the best projection is, sorry. And at the top, you have options to texture more or less the triangle. So typically at the top, we might have, like if I fill the holes there, we'd have some triangles that don't have any texture. So if you want to include them in, you can say invisible parts. So it will actually fill up every single triangle and give a texture to all of them. What you'll see here is that because we're all around, you might end up having textures from here applied on the other side because they might have a better orientation than those textures here. So you have to be a little bit careful. And so usually the one I use is at least one visible vertex. So that should not take more than a minute. We've got a little bit over time with that first exercise. I think it's probably sharing the screen fully might take a bit more time for my graphics card to work, but should be fine. What I might do is that I'll just go back to that. So yes, that's the texture, and that's what it looks like at the end with all the textures on it. So it looks very realistic. You can also give the colors from the point cloud, but you always get a much better result with the with real pictures, because then you have a really nice definition. And a little tip for those of you who do that often is that in the settings from 3DR, if you go into the meshes, there's actually a few options there where 3DR applies shedding on meshes automatically. And so when you say differentiate inside and out, that's where you have gold and blue. Shedding on inspected mesh, that's nice to understand still the shape of the mesh, even though you've got a heat map on it. But shedding on texture mesh, usually it's better to untick it because you already have shades from the natural pictures. So if you add the shades from 3DR on top of it, then it gets usually too dark. So it's good to untick that option. And what's the best format to export a textured mesh? It's OBJ format is the best one to do that. So what happens when you export an OBJ is that you've got your OBJ file plus the pictures, usually within a folder, and an MTL file. So it's important to keep all of those files together when you're opening that mesh in another software. Otherwise, you won't read the textures with it. Here we go. So that was our exercise. Get the point cloud ready, create the rough mesh, then refine it, and refine maybe local areas, etc. Improve the mesh, and then you can texture it with the real pictures, and you get a very nice realistic model there that you could use. You could use in a nice platform to show that beautiful church. Around. Here we go. That's the texture. So I might just show one more thing, and I'm conscious of time, but there's one thing that's interesting here is the textures, and it's the way to adjust the texture. I might not compute it, but just explain it to you. What's happening is that because this one is closer to it, it's actually taking its texture from this image position, but the angle of it is not that good. So it's actually better to texture the roof with the picture from here. And you don't really control that in the main function, but here you can adjust the texture manually. And as you can see here, it's pretty good looking. So I can actually in here select that image here and then select an area, just like when I'm doing a clean and separate, and say on this area there, please apply only the texture from here, from this picture. And I think I'm going to skip doing it because I don't want to take more time onto it. So that's the end of this exercise. I don't know, Lennon, if you've got any question that would make sense here.
I've got a couple more, but I think we just skip on to the next one in conscious of the time, and then if we at the end we maybe have a time to address them.
Yeah, okay, thanks. So the two next exercises are definitely going to be a little bit shorter. So hopefully we can still stick into the time we've got. We might have a bit less time for questions, but we'll answer all of them afterwards anyway. So hopefully you learned a lot about that first exercise. Second exercise is completely different, just a rural terrain workflow. So now we're going to look at UAV data. So what I'm going to do is that I'm going to just close this one and I won't save it. And we're just going to open the next one. Here we go. And we're going to go. So the first thing I'm going to do is just open this one actually. So if I just move to the first slide, what it opens, just to show you another example of the auto classification on a different type of data set. So I'm not going to play this one, I'm just going to show you the result. So let's move to it. Here we go. So that's our beautiful data capture with the EB drone. So we've got a few things here, a property, and then fields around it, a little bit of a hill at the back, a few trees, and a little tiny river going through. The classification gives us something like that. When you play it, what we see is that it actually didn't detect the vegetation. So I thought I would just show you how you can actually manually edit this classification. So that's what we're going to see here. And we see that all of that vegetation actually got put into the building class. So what you do is you set up the vegetation as the active class so that everything you'll select will go in the active class. What's happening though now is that if I select around, I'm going to get more, like I'm going to get the ground. So what you do is you hide the other ones. So I hide the ground and any other one, and I'm just looking at the building one. And now I can easily select this area, go around it, and potentially a bit more, and then zoom in and really go around like that. And even those are vegetation as well. And like that, if I click on enter, I'm validating my selection. And to add this one into the vegetation one, you just say add in active class. And if I do that, now this is vegetation. So this is how you can modify that. Potentially, if you've got more to do, you can also like explode the cloud and it will keep all those classes information in there and then regroup them into one and then like edit them and then group them into one, and then it will keep all those classes. But the manual way like that is pretty easy. So that was for this one. So what we see here is that the classification is actually very efficient to compute the ground. So if you wanted to have a DTM, that would be a very good way to do it. What you do is that you simply play the 3D meshing on it, for example. What I'm going to show you now, though, is that there is another tool to compute a DTM, which is the DTM extraction right here. So we'll go back to that. And what we'll do is that I'm just going to switch that back to real colors. And the DTM tool is into the surface modeling, and we have it right here, DTM. So that's actually not going to use the classification I've created. And what I'll do is that I'll do the same, just make sure I'm using the right setup, and I'll explain just afterwards. So this should be 3-4 minutes, not more. Yep, we'll do this one. Here we go. So what's great with this function is that you actually don't need to clean the cloud at all. You can just play it straight onto it, which is awesome because you get automatically the mesh from the ground points without having to do any manual cleaning. You might have to edit that mesh a little bit, which is often the case. Like there's hardly any fully automated tool that gives you 100% result, but at least you'll only have a few little tweaks to do around the area. So the way it works here is that you first actually define a grid size, and this will give us approximately the size of the triangles again that are going to be created over this big area. So I've entered 1 meter in there because I'd like to have nice details. You can see here with the scale, this is 40 meters. So this data set is much larger, definitely a few hundred meters by a few hundred meters. So the smaller the value here, the longer the computation. But it's nice to have a bit of detail, so it's nice to have a value a little bit smaller. So what's going to happen is that 3DR in the background creates a grid of points that are a meter apart from each other that is kind of overlaid over the mesh, but all into one plane. And then you define here the direction in which you want to look at. When you're extracting a terrain, you're always going to use the Z value. If you're on a cliff, for example, you could use here a direction that's perpendicular to the cliff, and that will give you better results. Because what it's going to do, basically, it's going to try to look for the lowest point in that direction, no matter what direction you're choosing. So we usually use this for DTM, but you could actually use it for other stuff potentially as well. So what it will do is that grid in the background, it will first find the lowest point and bring the point that corresponds to it down to that lowest point on the point cloud. And then we have here an angle in there, and this is max slope of the terrain. So what we have to look at is what we actually want to extract from that terrain. So if we're just after the grass area and so on, there's probably not a too big slope there on it. But if we want to keep the hills in the background, we need to allow for a certain angle. And so you always try to enter here an angle that corresponds slightly to the slopes that you would like to keep inside the data. So if you go flatter, it will cut out those, but if you go steeper, it will really go through everything. The risk is though that you might get too many details into the data. So maybe while it's computing that, we could take a couple questions again.
Sure. So back to the two-step meshing. In stage 2, do you need to consider the accuracy of the data capture when estimating the deviation error?
Yes, I think you need to keep that in mind. When you're refining with the point cloud, so when you're not doing the interpolation, you definitely need to take that into account. You cannot go lower than the quality of your point cloud. But when you're doing the cloud interpolation, you could enter a value that's much smaller because you will have finer details, because it is marked in the background and it will find the best points to use, basically.
Yeah, right. So it'll smooth out any noise in the data, essentially.
Exactly. So computation is done, so I think I'll keep going. What I really like doing here is show and hide the cloud now to see what has been done. So if I just hide all of them, here is our mesh. So we can see that we get the hills, and I really love looking at the little rivers usually like that, but you can also see the roads that are going through the path and all of that. And here maybe some water flowing down from here as well. And if you show the points just on the ground, here you understand what has been done. And what I would try to look for is that here I can see there's a little part that's been chopped out, and that's probably because my angle is not steep enough. So if you wanted to correct that, you should go steeper, or you could potentially cut that out of the cloud and do a refine locally, just like we've done with the church earlier. Other thing that can happen is that here you might grab points that are actually not on the ground, and this is what's happening here with the roof. And this is because my angle is too steep, so I probably need to go a bit flatter so that I would not get that. If I use a grid that's bigger, like if I had used 10 meters, I would have probably avoided the building as well. So I used one so I can show you a nice looking mesh, but potentially, depending what you're looking at doing on this terrain, 10 meters might be plenty enough to represent it anyway. So always remember to choose a value that makes sense for what you'd like to do with the data afterwards. And I always choose refined here. That's important, because that way, if I just hide that again, the triangles are organized nicely along the curves and the edges of the natural terrain that you see, and you have nice defined potential break lines and all of that. So I'll say okay to that. And so as a result, we have the mesh, but we also have the point clouds, so the different groups. So it's a bit of another classification. So this was here way before that new auto classification was there. So this is just ground and so on. So what I'll show you here is simply how to correct the mesh. So if I want to get rid of that building, there's an awesome function that I think not everyone knows about. Where is it now? Here, replace a point. So select your mesh, and if you go there, then you can manually go around the area, and I hope you can see my white lightning there, and you try to go onto triangles that are flat around the area, and what it will do, as soon as I let go, it will compute what should go there instead of what is there at the moment. And because I'm going through all the flat area, it's actually just removing all the triangles and filling it flat. And you see here we've got the same options as with the hole fillings. I could fill it with curvature as well, but in our case we just want to get rid of the building. So super simple. And so you could use that in this function to remove potentially a couple trees that are still in and things like that. So you'd probably show the point cloud to see what's happening, but that's a very nice way of improving the mesh. Here we go. So that's this. Then one thing Lennon was saying was good to show is how to actually get data like that back into CAD, because you might want to have your DTM in CAD and start designing, who knows, like a retaining wall or a new quarry or a pond somewhere or a water dam potentially somewhere, and understand things like that, where you might want to go to CAD to design that with all sorts of other information you might have. So there's different ways, and I'm going to show you one that probably might be what everyone might be looking for, is that in the extract, let me just save that again just to make sure we're all good. And I'll just call it 1. So I think one of the main things that people are usually after is extracting grid points from here. So how do you do that? It's in the extract menu. You select your mesh, and then here from points, you can do grid points. So it's always better to first create a mesh, because then you have a full surface and that grid can now be perfectly regular. So I'm just choosing a grid of 5 by 5. And because I've got a mesh, the extraction will be very instant actually. And you'll see here, we've got a regular point cloud. I'll say okay so that we don't see the mesh anymore. If I hide the mesh, that's what we're getting. And we're still having the shapes, but very regular points. So that's very light data to then bring into CAD. You could mesh that again and then send the mesh to CAD if that was the best way to go. So that's probably where you'd use one of those other meshing techniques where you say just mesh all the points instead of mesh in 3D and fill the holes and all of that. Another thing you could do, I'm just going to hide that, is that you could also compute contour lines and get that over. So I'm going to go to extract and do here the, where are my contour lines? Here, contour lines. And what's nice is that those contour lines actually get names and all. I'll hit preview. So I'm creating one contour lines every 1 meter. Very instant because you're straight onto a mesh, and I've got a major contour line every 10 meter. So, and I'm choosing to show the altitude, only the elevation, only on the major contours. And so I hope you can see it. Those major ones are a bit thicker, and you've got the elevation showing up there. So this is a very easy tool, but it's not just polylines. They have a little bit more information because they've got that. So I think what would be nice for you to see now is see how that actually shows up in CAD. So if I've got those two things, I can actually select them like that, and then go File and Export. And you can simply export all of those into a DXF, which makes it very easy because you put it all into one file. So I just choose DXF, and then you save it like that. So what I'm going to do is that I'm just going to open. So I don't have a license of AutoCAD myself, but I've got BricsCAD. So I'm just going to show you the file that I saved yesterday. If that opens. Here we go, drafting. Okay, it's opening. So the file itself is this one. Okay. It's just taking a minute. So I'm just going to bring that onto that screen. Here we go. And then do the terrain and grid. If I go into the top view, here you go. So you get your contour straight in and your points. And on your contours, you can have even the writing, and you can choose how often do you want it. I think I said every 10 meters here, so that's quite often, but it can be quite a bit smarter than just lines like that. Okay, I think we're done with that exercise with the things we wanted to see. So I'll just switch. There's a tiny thing I didn't show you, but we're just having a bit to battle with the time now. So you could also color the terrain with elevation, and that can match the contour lines, which can look pretty neat. And from there, you can compute volumes, etc. So Lennon, do you have maybe one question on this particular exercise? Otherwise, we'll move to the next one.
Yeah, a short one. Those contours that come through have the correct coordinates and height, is that right?
Yes.
Cool.
Yeah, absolutely. It goes through in full 3D, so you'd have the right coordinates that are the exact same one as the mesh or the point cloud that they're originated from.
Perfect.
Thank you. So this was quite an easy exercise, really. Like working with UAV data on terrains is something that's quite easy in 3DR. So last but not least, exercise there, and I'll try not to go too much over time. Hopefully you're still all available to keep going on with us. This is probably a bit a harder exercise in 3DR because that's a lot of things that people would like to see automated a bit more, but it's not fully automated yet, and there's no magic button yet to just extract everything you'd like to get from a road. But there are definitely a few tools there that can help, and so that's what we'll do. So I'm going to skip the first part because I'm conscious of time. What I had with that data set is that, so I'm just going to say it and I'll just work on my finished point cloud. This data set is actually one I've got inside my Cyclone core databases. So what happens is that through that CloudWorks menu that you have with 3DR, I don't know if all of you had realized, but you can obviously import LGSs, but you can also directly connect to Cyclone Enterprise or Register 360 or Cyclone Core. You do need a publisher license in the background to be able to do that. So not everyone might be able to, but it's I think it's a great workflow, because it means that if you don't want to export the LGS just yet, or you actually don't need it, then you can straight in 3DI connect to your database and open the data. What you do is that then it works the same way as when you import an LGS. You have your point cloud in there, and to start working on it, you do need to convert it. So if you want to do the auto classification or doing the meshing or anything like that, you do need to convert it. And so what's nice, one thing I'm skipping, but hopefully you'd be easy enough to do that, is that you can use clipping boxes and the slices inside the CloudWorks menu to show only the part of the data that you're after. So that way you only convert, for example, here, I only want to extract the lines on this intersection and the traffic lights there. So I'm only going to convert this middle part and not the entire road that I had been scanning. So that's a nice way to work like that. Here we go. So now I'm going to flick to the file itself, and I'm just going to open the finished one so that we saved a little bit of time, but I'm still going to show you what we wanted to show you. I just have to do that, open with Studio. So again, a nice tool to use on the data is that auto classification. So I thought it was a good idea to show it because it's a new tool. Show it in different data sets. I might just close BricsCAD in the background. That might help a little bit. So because I saved the file with the link to the Cyclone database, it's still having it inside the file. So if my database is still on my computer, it will open it, and that's what it's trying to do now. It's connecting to the database to still be able to display it. If ever you've got another question, Leonard, while this is loading.
Yeah, there was a question I think I can answer about the new classification tool, where it comes from and how it works. So it's developed by Hexagon, which is the parent company of Leica, in their innovation group. And so lots of Hexagon companies draw upon this technology and integrate them into their products. And so it uses AI and machine learning, so it's constantly fed with new data sets. So you can expect it to get better with time. I don't know how it works. I don't pretend to know how it works. But what we've seen is it does a really nice job in, save on the road and the UAV data sets. It's excellent at getting that ground surface quite accurately. And then anything above it, yeah, as we saw, the trees were classified as buildings. And so there's a bit of manual work to get those classified objects correct, but there's that tool there that allows you to do it. But essentially, if you're going for a road surface or a terrain surface, you know, there's not a lot of manual editing required from our experience. So that's a quick comment on that.
Yeah, that's good. I think a bit like any tool like that is that it's the first version of it that's out, and we can see that it's working like it's doing a lot of it, a lot of good for us already. And you can see right now on that road, after the classification, like for example, what I was very happy with, that the ground is absolutely perfect. You can see that's really following through, and that's great because that's probably one of the main thing that we're after when we want to classify. But the second thing I really loved is that it picked out all that traffic and put it in a separate layer. I don't even care what it's called, but if I explode the classes then like that, I can get rid of all of that straight away without thinking too much. We still have a few of those cars that were probably a bit more static while the scan was going on, so they're considered like, I think they call it hardscape. So there's definitely going to be improvement in there. There's no doubt there, in the future, and potentially now that it's out with customer feedback, they might know a bit more in which direction to make the improvement. But I think just looking at that can save some time already, really. Just splitting the cloud like this. So I'm quite excited by this new function. So here, I'm going to try to go straight to the point, which are the interesting things about that road. So I'm going to skip a couple things. Basically here, I've got the ground. I've split by classes, which is what we've seen earlier, this one, explode by classes. Once you have your classes, you can explode them. And so if I show only the ground, we have something that looks pretty good, honestly. To mesh that, so first exercise I wanted to show you is how to extract curb lines in the best way. So there's different ways. You can either pick points yourself on the point cloud, and you can use the smart picks that are under those functionalities, like drawing a polyline or drawing a CAD curve. But I'd like to show you something a little bit more automated. And for that, what I did is that from this cloud, I played the DTM extraction, just what we just saw with the terrain. And so I got this mesh here. So I'm going to go straight to that because I don't need to show you the detail. And I got that mesh. So I meshed at 200 mils. So my triangles are about 200 mils big. If I just switch to flatten wire, that's what you'll see here. But I ticked the refined option, which means that I do have nicely refined edges wherever I do have details. And so that's what I need to be able to extract those lines. So there's two functions that could be interesting to extract curb lines is the break lines. You can have just single break line or multiple break lines. If you have a bigger terrain, you could do multiple. It's just a little bit of editing to then keep only the ones that are actually relevant for you. But so I'm going to show you just a single one. In single one, what I like is that you manipulate it yourself. You choose where it is, but you don't need to click too many points. So I'm going to say I want it to be just concave and convex, not go from one to the other. So, and you have to pick a point really in, like we're doing the bottom of the curve now. And so like that, by clicking just a few points, it finds automatically the break line that I'm trying to follow, basically. And so like that, just clicking 4 points, I'm having it. If ever it doesn't go the right way, I can just delete the last point, click more points, and keep going like that. So this is quite an easy function to use. It used to be quite complex in the dialog box, but they've made it much easier today. What you have to do though is, as you can see, that polyline is a little bit fuzzy. So what I'm going to do, and here it's going through the water hole on the side. So we actually want to cut that. So I'm going to show you how that works. There's a lot of smart tools to edit polylines, and this is in the clean menu, and it's on the right here, polyline edition. So they're all very hidden, which I find is a bit of a shame. But if you go into the edit part, you have all those tools that are absolutely awesome. And I think everyone probably needs them once you start extracting polylines. A great one is this one, replace a portion. What I can do is pick 2 points there, then say I want to replace this part, select it, click on enter, and I say I want to have a curve, not a straight, a curve in there. And then you can even modify those bowls there to really get it the way you want. And if you wanted to, you can say, I want to keep it projected onto that mesh. And that way, that little section is still exactly on the mesh, but it's kind of interpolating where it's supposed to be. So replace a portion, very useful one. It's very much the same as replace a part for the meshing. I'll say okay. And last thing we probably want to do with that is smooth it out because it's a little bit too clunky at the moment. So select the polyline, edit, and then you have that smooth option here. And when you smooth, we can go height smooth and go as high as you can. And here you'll see that the pink line is the smoothed one. Potentially you can play this smoothing a few times so that you smooth it much more. And if I say, okay, now I'm having a line, that's much more what I would be after. So doing it like that manually, you'd have to extract the bottom and top manually and click a few points, but you get something not too badly, very easily. Once you know a bit all those little tools, you can get that very easily. And you can get around those as well, etc. I won't go into detail there because we have to stay on time, but hopefully you're getting the idea there. So that's one thing I wanted to show you. And then there's one more thing that I wanted to show you, and it's, I think we're going to stay on the ground as well. We're going to go back onto the ground cloud. Oh, not this one, sorry. I'm going to go here on the ground cloud. So if you've extracted it, I'm going to show that only. And now I'm going to show you how to do the white lines. And there's a little idea that could be interesting, is that when you look at the inspection value, that's actually the intensity value back from the scanner. You can see that the white lines are usually nice, reflective. What we can do is that if you double click on that cloud, you can actually modify that color scale yourself. And what we can do is through the preset, I can say I want regular steps and I only want to have one step, two steps, sorry, to have two ranges of colors. And what you'll see now is that if I slightly move that, you'll see that all of a sudden the white lines are very distinct from the rest of the road. So like that, if I validate this, it's actually possible to explode this point cloud from inspection steps right here. So if I do that, now it's going to explode in two different point clouds, one with the red part and one with the blue part. And you could do that straight on the full point cloud. It wouldn't have to extract the ground, but it's just cleaner if you do extract the ground. So I'm going to hide that. And then that's something you could potentially script as well. And I'm just going to have one very, very quick word on scripting once we're done. But I'm showing you the workflow. Once we have that, what we can do now is explode the cloud by distance. That's a function I use very often, even just to do some cleaning on the cloud at the start. And let me just see what I used. 0.5 meter will be fine. Here we go. What this function does is that it just looks at individual clusters and it will cut the cloud with different points. I might have to go just a tiny bit smaller. And then you see individual colors for the clouds that are extracted. So looks like these in the middle, not fully. So I'm just going to go a tiny bit smaller. So if I put a value that's smaller, it will eventually find those individually as well, which is what we're seeing right now. If you go extremely small, then eventually you'll have every single point in a individual cluster, which is not what we want. And I can say just delete whatever is smaller than 100 points because we don't need to create that. But if I say OK now, that's actually creating all those individual points and you see them here. And so there's a nice idea, and I might just use those here to create white lines. I might just show only those. Is that now that those clouds are individual, It's nice and neat. What I can do is select them all, and in the extract, I could, for example, here compute a best line for each one of them. So if I do that, what's important to tick is this option, one shape per input, which means we're going to have one line per white line. And that's how you could get a bit of the curve here, for example. And so if I do a preview, I'm just going to hide those labels. What we see now is that you've got one line for each. Potentially, you may actually want to have just one big line for each segment. In that case, you just select all of those together and you untick that option, and then it computes one line going through all of them. What I did like is that if you did want to draw those individually, you could actually have still that curved information there with here. So what I'll do is that I might just show you here and hide the cloud. Here we go. So here are the lines that you could potentially have. Once you've got that, super easy to just export that again to CAD and potentially add your coding into it or whatever. So that's something that's not possible in 3DR. You cannot do coding to just come and add a crossing, for example, a pedestrian crossing and things like that. But this exercise was to show you little tools that could be useful to extract features from the road in a bit of more automated way than just picking points. And so the last one that I did want to show you, I'm just going to go back in the main cloud, is how to extract electric lines. And that's when I'm just going to talk a little bit about scripting, because 3DR have themselves written some scripts and put them available here. The idea being that they're not a full function, so it's a little bit lower maintenance for them, but it could be interesting for you to actually look at those, because you do have the code of it, and then you can make it your own and potentially use it and adapt it to whatever you need to do. So that script here, it's telling you click the cloud. So I'm clicking on the cloud, and then it says click a seed point. So I click a seed point on the electric line I want to extract, and it's creating a polyline like that. And so each time you want to extract the others, you just click on play, select the point, select a seed point, and you can see this one, it even went all the way further. So super easy. You could add some lines at the end to just have the script on repeat, so you don't need to click on play each time, and you just keep going, but like that. That's to give you a bit of ideas, and that's what Lennon said at the very start to the presentation, is that if there's stuff that are actually not exactly what you need in 3DI, you have the possibility to script them yourself. So scripting can be good either to create a new functionality like this one, or also automate a whole process. So like that white line extraction, for example, could easily be automated and written in a script, as long as you're working on the same type of data. And that's it for that example. I think we haven't done too badly. I'll just finish my slides. That's what I showed you, extracting the curb lines, extracting the white lines. That's a bit of an idea that's available out there, and scripting. And you can extract all of those polylines into one big jigsaw. Get that into CAD if you need to. Here we go. Thank you very much for your patience and sticking with us that late. Sorry for going over time. I hope it was worth it anyway. So Lennon, your call if you want to have a few questions still.
Yeah, I mean, yeah, sorry for running over time, but it looks like pretty much everyone is stuck with us. So
Awesome.
I think that shows the quality of your presentation, Jennifer. So thanks so much.
Thank you. I hope I didn't go too quickly either and didn't lose too many people on the way.
No, it's great, and it's we've recorded this. It'll be posted on the ArchNZ website, so it'll be a great resource for people to revisit. A couple of quick questions, I reckon, to finish. There was Another question from Rodney. So if you had in the DTM tool, say you had some rolling terrain and then there was a quarry in the middle of it. So you've got some kind of very steep terrain together with some less steep terrain. What would you suggest a strategy for that would be?
Yeah, I think that's always a bit what's tricky with that function. So it depends a bit what it looks like. If it's just a little area, I would probably try to still keep the main part of the terrain. Maybe that would erase that smaller part in there that has that quarry and all of that, and then just cut the quarry out of the point cloud and mesh it on its own, and then integrate it in the DTM afterwards. So you'd cut the DTM where the query is supposed to fit in, and then integrate that mesh in. So it's a little bit more manual. That's one thing I didn't show you during that presentation, but potentially I could do a quick video and send that to Lennon to upload on your platform as well. If it's a bigger query, like if the whole site is a query, and obviously on the side of it are quite steep, then you probably just cannot really use the DTM function,
Mhm.
because by default it will never create a vertical surface. So you probably have to try to clean the data in a other way and then go for the 3D meshing option. So hopefully with that auto classification, that can bring a bit more ease in cleaning the data before going into the meshing.
Yeah, perfect. And I like the same way you refined the door of the church from the cloud. You could also do a DTM and then select just the quarry part and refine that, assuming it's clean. So I think there's a couple of different workflows.
Yeah, you could, but not if it's too far from the point cloud. Like if from the mesh, I mean, if the mesh is really perfectly flat and I mean, it's a bit hard to say because on that door, those details were really engraved on the door. If I had like what can I say, like a flagpole really sticking out a meter out of that door, I wouldn't have really retrieved it in a nice way.
Yeah, right. Okay, so running it in two steps sounds like a bit like two separate extractions and then
Yeah,
joining
I
up.
think, yeah, it depends on the data. It's a bit hard to be too general, but that's what I
Yeah,
would say.
cool. And then in the extracting polylines, so the break lines, is it possible to extract a line parallel to that line with a particular offset, or could you do that as a second step?
Yes, yes. Let me just switch to that. There is an offset function which is in the coordinate system. So in coordinate system, you've got tools to move or copy and move. And what you could do is that I'm just going to select the one line here. You have an offset here. So you just define the plane of the offset. That's the only thing you need to get your head around. But once you've got that, I might just select, like if I do a Z direction is actually a plane like that. So here you're defining the normal of the plane in which the offset is going to be done in. So if I want a horizontal offset, I put just the Z value here. So the orientation is Z, but then the offset is going to be done horizontally. And then that line will be offset 1 meter, one way or the other. And you can create several copies even like that. So yes, that would be the way to go.
Perfect. And then I think one more. You showed how you could best fit a line to those dashes of point cloud. Could you extract the extents of the point clouds and automatically extract a line around the dashed line rather than best fit the center? So I guess you'd extract a rectangle around the white line.
Oh, the white lines. Yes. So you could. There's one thing that I wanted to clarify and I didn't manage to, but if I just show only, what's happening inside Reshaper is that if you have a best rectangle here, option, but this actually computes a best rectangle, which means it's not an outside rectangle, it's a best rectangle. So I think the way to do that would be to actually measure, and you'd probably know what the width should be, like 136, and then we can potentially just force that here. I would say width, and is that what I said? Yeah, and then the length as well. So I think it's going to the right because I've got a few points here, but that would be a little bit the way to go. There used to be an option to say the best outside rectangle, and I'm just not quite sure whether it's still possible in there or just in the scripting. I wasn't sure about that.
Okay, that's great. All right, I think we'll close the questions there. Please chuck them in the chat if you want us to answer them afterwards, or send us a mail and we'll be happy to get back in touch. And then I'm just going to quickly conclude. So if I...
Should I stop the sharing or can you take it back?
Yeah, can you send the sharing back to me, Jennifer?
Here we go, that should work.
Great. Okay, and then a quick wrap up. So thanks for sticking with us. We're going to have our next session planned in the new year. So in February, when everyone's back from a nice break and has tidied up everything they need to. So February at this stage, and we're in discussion with a couple of different people about possible presentations. So we'll send out the topic as soon as it's been defined. Please feel free to get in touch if you have any feedback on today's session, or if you have any ideas for future presentations. We'd be really happy to have you present. So please reach out. Please join the LinkedIn group and interact on there. Please feel free to share your work. Doesn't have to go through us. It's your page. Please make use of it. And let us know, if there's any ideas for the future. Other than that, wish you a very Merry Christmas. Have a great break, and we look forward to getting back together in the new year. Cheers.